Unlike pipes, ducting, and other service items which can be fire stopped and forgotten, low voltage wiring, such as voice and data cabling, almost always require future access. This presents a problem for traditional fire stop methods because many of these products are installed wet and then cured to form a permanent fire stop seal. This makes future retrofit difficult and time-consuming since the cables are literally glued together as the fire stop compound cures. There are, however, alternative solutions available for sealing high-traffic openings and smoke and fire barriers, which allow you to easily handle future retrofits. In this video, we'll discuss how to determine what products and methods should be used to properly fire stop high-traffic openings with retrofit in mind. Most fire stop materials are designed to be installed once and left alone, which is fine unless future access is needed. Penetrations in fire barriers that may require future access are known as high-traffic openings. The most common examples include cabling through interduct, sleeves, tray, and raceways. A common example is a penetration made in a temporary smoke or fire barrier. While these openings must be properly sealed, a re-enterable fire stop material simplifies the work when changes are made. Naturally, the amount of change that an opening sees differs from one facility to another, making a universal definition for the term high traffic impossible. For this reason, many facilities have carefully reviewed which penetrations require the most frequent access and physically labeled them as high traffic to remove any confusion in the field. Traditional fire stop compounds such as caulk and mortar are not considered re-enterable or retrofittable because they're installed wet and then cure or dry, making them labor-intensive to remove and expensive to replace. Re-enterable or retrofittable are industry terms describing fire stop materials that are specifically designed for high-traffic openings because they can be easily removed and replaced.
Products such as Firestop Pillows, non-curing putties, and newer pathway devices are quick and easy to change and are by far the most popular fire stop choice for high-traffic openings.
While re-enterable fire stop materials may cost more initially, they quickly pay for themselves as they don't need to be replaced each time there's a change.
Other traditional products used in high-traffic applications include foam bricks and intumescent composite sheets. While both of these products do not meet our definition as true high-traffic products, easily installed and reusable, both, however, are aesthetically pleasing as installed and are well suited for closing down larger openings. The key for both types of products is to design uses where once installed, removal will not be required for future cable changes. An example of this is the use of composite sheets in conjunction with newly developed self-contained Firestop Pathway devices, which we will discuss in greater depth later.
Clearly, many different approaches exist, all of which are legitimate products with UL Firestop listed systems. The key to system selection in high-traffic openings is thoroughly understanding the differences of each, so that it is clear not only how easy or difficult a system is to install initially, but also during the many retrofit cycles anticipated over time. Not only will this careful selection process minimize operating costs and improve compliance, but it will also help to ensure life safety. Once you have determined that a penetration is indeed high traffic, the next step is to find a UL system that permits a re-enterable fire stop. Many facilities have standardized operating practices that specify this for you. The UL system drawing dictates what products may be used and how they may be installed for your specific application. To locate the proper UL system, consult the System Drawing Index at the front of the UL Fire Resistance Directory. It is here that you will learn if re-enterable products like putty and pillows are permitted, or if a more permanent product must be used. In addition, the system information will dictate such things as how the materials must be installed, what accessories are required, and limit such variables as the number, load, size, and type of cables, sleeves, and trays. For example, if we have a small cable bundle through a sleeved opening in a 2-hour gypsum wall, we might search for a system drawing and find that we can achieve a 1 or 2 hour rating by installing a 5/8 inch depth of either Firestop sealant or putty. Because we want a re-entrable material, the system using putty would be favored. However, that same system has a maximum cable load limit of 47%. So if your as-built condition exceeded that amount, well, you'd have to either reduce the number of cables in the sleeve or continue searching for another system that permitted a greater cable load. If you come across a non-standard penetration that the UL system drawing doesn't address, you should notify a supervisor who will contact the factory for installation instructions specific to your application. Now, it's important to remember to never install Firestop without proper documentation. This is your evidence of compliance, which may be required by an authority having jurisdiction. And by strictly following the installation instructions in the UL system information, costly mistakes and liability can be avoided. While all this may seem like overkill, it's done because Firestop is easily prone to misinstallation, especially in cable applications. Cable jacketing is a source of fuel that burns rapidly and releases lethal gases during combustion. When these cables are bundled together, the fuel load grows significantly and permits a fire to easily breach a fire barrier. This makes the installation of Firestop extremely critical. While putty and pillows are intumescent and expand with heat, there are limits to what they can do, and these limitations are clearly spelled out in the UL system information. As discussed earlier, mortar and caulking compounds are installed wet and cured to form a tough seal. Firestop putty, by contrast, behaves more like molding clay and is designed to remain pliable over time. This feature not only permits faster re-entry, but also saves money, as the same putty can be removed and, as long as it's kept clean, reshaped to form a new seal after cable changes are made. It's important to recognize, however, that Firestop putties are designed for smaller openings such as cable bundles and sleeves, and are not designed for large annular spaces such as around cable trays. Because putty doesn't flow easily between cables like caulking compound does, in cable bundles there's a maximum diameter that can be effectively sealed using putty. Caution should be exercised to ensure you don't exceed the maximum diameter. Only a few systems using putty can address cable bundles over 2 inches.
The fact that putty can be removed and cables so easily added does make it a good choice for cable applications. However, this also means that unless great care is exercised, cables may be added until the sleeve is filled with cables and no fire stopping remains. Thus, vigilance is required to make sure that cable penetrations remain compliant. A more foolproof approach to Firestop cable penetrations is the use of newly developed self-contained Firestop pathway devices. These pathways can be installed around existing cables or installed in advance of the cabling process. The built-in fire stopping protection is permanent and need not be removed in order to add cables. This makes cable moves, adds, and changes a great deal easier and safer. Users also benefit from the fact that one easy installation provides both the cable raceway and the fire stopping in the same simple step. The fire stopping system automatically adjusts from empty with no cables to full and everywhere in between, allowing them to be installed during construction or in anticipation of future capacity requirements. When exposed to fire, built-in intumescent inserts quickly expand to tightly seal the pathway and block the spread of fire. Another advantage of these devices is greater control of smoke leakage. The area between cables, referred to as interstitial space, is very difficult to seal, especially with putty. The larger the cable bundle, the greater the amount of leakage we can expect through the penetration. While some UL classified systems utilizing putty for cable penetrations do have the optional L rating, regular steel sleeves are unsealed as installed. And even when sealed, the amount of leakage will vary according to the size of the sleeve, the amount of cables installed, and how good a sealing job the applicator has managed to do. Fire-stopped pathway devices sealed as installed and utilizing a fixed cable volume provide predictable leakage values which greatly assist in the process of smoke leakage compliance.
In larger openings, such as cable tray penetrations where putty is inappropriate, the Firestop pillow is ideally suited. The principle behind the Firestop pillow is similar to that of sandbags, which are compressed and packed tightly together, except that pillows are designed to hold back the products of combustion rather than water. There are many different versions on the market, but they all have one thing in common. They must be compressed a minimum percentage into the opening. While the percentage varies by manufacturer, proper compression is critical to the performance in a fire. The most user-friendly are those that compress easily and then recover quickly after compression. Another important feature that makes pillows easy to use is having a smooth outer surface that permits easy insertion and removal during retrofits. The most popular pillows are made from blocks of mineral fiber that are coated on all sides with an intumescent coating and enclosed in a polyethylene liner. Here's how they work. During a fire, the polyethylene bag shrinks away in seconds, exposing the intumescent core. As the combustible cable jacketing burns away, voids open up and each pillow begins to expand.
The combined effect of all pillows expanding simultaneously fuses them together in a solid, monolithic char that blocks the passage of smoke, flames, and superheated gases for up to 4 hours.
The performance of a Firestop system in a real fire is largely a function of how it's installed. Now, while care must be taken during the UL system selection, the work's not complicated. The skills needed to install these products are common, but the willingness to comply with the requirements spelled out in the UL system is not. Being designed to remain pliable, Firestop Putty very easily takes on whatever shape you give it, making putty extremely simple to install. The requirements for putty vary dramatically from one UL system to another, so it's critical that you confirm such variables as cable diameter, putty thickness, annular space, and mineral wool requirements. Once you are sure that your application can be properly sealed using putty, most installations are simply a matter of forming the putty into a rod. The diameter of the rod should be equal to the minimum putty thickness required in the UL system information. When mineral wool is required, be sure to recess it into the opening, leaving enough room for the proper depth of putty. Then bend the rod of putty around the cable bundle and between the cables if any gaps are present or the spacing allows it. Form a secure bond to both the cable bundle and the surrounding construction, in this case a metal sleeve. Wall systems require a symmetrical seal, so be sure to seal the other side in the same manner. When removing putty for retrofit, be sure to set it aside in a clean location to keep it from becoming contaminated with gypsum dust or other debris. Dust is a bond breaker and prevents adhesion during replacement. If the putty becomes contaminated, it should be replaced.
The fire-rated Pathway is a self-contained unit that is quick and easy to install. Pathway devices eliminate a lot of decision-making. UL classified for 0 to 100% visual fill, these products require no complicated calculations. Cables can simply be installed until the pathway has been filled. For new cable installations, a properly sized hole is cut in the wall and the wireway unit is slid into place. Wall plates secured to the pathway with set screws lock the wireway in position with no mechanical attachment to the wall. When installing around pre-existing cables, the wireway is easily split and reassembled around cable bundles and slid into the wall to effectively restore the fire barrier integrity. The wireway self-contained Firestop system may be installed as a single unit, or for additional capacity or segregation of cables by use or trade, the pathways can be gang-mounted using convenient mounting wall plates for up to 7 devices. A variety of accessories allow these pathways to adapt to a wide variety of wall and floor applications.
Like putty, pillows also are simple to install. But to work properly in a fire, they must be compressed tightly into an opening, and every brand of pillow requires a different amount of compression. Therefore, unlike putty, some simple arithmetic is required to calculate how many pillows are needed for each opening. The pillows we're using for this demonstration require a minimum compression factor of 1.4. Remember, even though compression rates vary depending on the brand of pillow you use, calculating the number of pillows needed is simple arithmetic. We start by calculating our opening size, which in this case is 11 inches high by 18 inches wide, or 198 square inches. Next, we calculate the area taken up by the tray and cable load. Now, the tray is 4 inches high and 12 inches wide, which would take up 48 square inches if fully loaded. In this case, the load is approximately 2 inches deep on average across the entire width of the tray, or 24 square inches. Now, because the depth of a cable load isn't uniform, you'll need to do some estimation. Estimate on the safe side, figuring the bundle takes up less space than it actually does. By subtracting the area taken up by the tray and cable load, 24 square inches, from the overall area of the opening, 198 square inches, we find that we have 174 square inches to seal. Simply multiplying that amount by the compression factor of 1.4 reveals that we need 243.6 total square inches worth of pillows to obtain necessary compression. To determine how many pillows we need, we divide this number by whatever pillow size we plan to use and round up to the next one. To help you address a wide range of openings, pillows come in a variety of sizes. The pillows we're using for this demonstration come in 4 sizes, from 4 to 18 square inches, all of which are 9 inches long. If we use the largest size and divide 18 into 243.6, we realize that we need 13.53 pillows. By simply rounding up, we find that 14 of the 18-inch pillows are needed. In reality, the largest pillows may not fit well, requiring the use of other sizes. This is perfectly acceptable, provided that the overall combination of pillows achieves the 1.4 compression rate. Once in place, look for small gaps or openings that couldn't be sealed by the pillows. Later, when small cable changes are necessary, a single pillow can be removed and replaced without having to remove and rebuild all of the pillows again. For more substantial cable jobs, the pillows can simply be removed down to the tray level without disturbing the pillows below, the new cables added, and the system easily restored to its proper rating. If a substantial number of new cables are added, you may need to recalculate the number of pillows needed to ensure that the proper compression rate is maintained. Properly sealing cables isn't difficult, but it does require some effort to research the proper installation requirements. Well, one useful tip to help speed the time needed to do this work is to standardize around certain UL systems. This way, you can memorize the specifics and avoid researching each and every opening that you encounter.